Welcome. Uh, Thanks for joining. Hope everybody can hear me. Just let me know if you're hearing me all right, and we'll start soon in a second. We're waiting for Dr. Doorbell, so give us just a second. And I see a bunch of you out there already in the audience, so thanks for joining once again. And how you all doing? So we'll just be second till we get started here. And just type in where you at in the world. So I see already hands. Okay, he typed Qberry Farm. Okay, awesome. So everybody welcome. We can wait for a few minutes, see if Wayne joins. If not, he might be busy somewhere, so we can watch a replay from last week. And we have an excellent video lined up. So if Wayne um has problem signing in, joining up, then we can watch this video in a second. But first of all, how you all doing? Just type in how you all doing, where you at, and a bunch of you already joined. Thanks everybody. And as you know, this is our Colonomic Action Team's weekly live podcast, Talk with Wayne. And we are missing Wayne. So in just a couple of minutes, we'll watch a replay. And this is an amazing, awesome video that we're going to show you today in just a minute. But let's see if Wayne joins. If not, we'll get started in a minute. So we'll get just give it a few more minutes, and then we'll start this video. And just let me know how you all are. So Alicia says hello. All right. Hello to Alicia. Thanks as always, everybody who's here. All right. All right. So okay. Tell you what. Let's all watch this video. This is a replay from Mark Shepard's Forest Ecology. And let's get started.
Hey everybody, Wayne and Mark. Mark is in his car and got the webcam kind of looking down so we get a little different view there. One announcement, that's all we're going to have because we've got actually, and that's what it's going to be, we're having a webinar once a week now in which we do our announcements and do questions and answers and stuff. And so that's when we're going to do that. We're going to let our speakers have all the time. But I want to just one other one. I am starting to publish, or we are, and we're only into about 4 or 5 of the sessions, but we'll get them finished probably by the end of next week to where you can actually, when you're doing replays, you can listen to just the audio. So we're putting like a podcast player inside your sites. So if you want to just listen to audio on a replay or you want to download it, you can do that. So be looking for that as we come. So by the way, Sam says it's 55 today up in where he's at. So all yours, Mark. Go for it.
All right. Well, a little notice update from my side of things. You guys here the last couple of weeks. I don't know how much I told you about my leg. I know I had just gone to the doctor and they said that the bottom part hopefully will fix itself and or they could do surgery if it doesn't fix itself. Well, new information from new MRIs shows that the thigh muscle itself, the rectus femoris, is blown apart and it's not worth trying to fix. So anybody with some good alternative how to make the largest muscle in your leg reconnect to itself, really appreciate that. So that's a little bit of a depressing news. But anyway, it's back to our conversation on succession and how it applies to us as restoration agriculture practitioners. And my screen didn't advance, it will now, right? Hello, advance, there we go.
While it's advancing, by the way, we got a funny one I got to throw in. So when Ada put in, or Adam put in duct tape.
Work on the duct tape, all right? That there is only one and only one solution, and we have almost no time to do it. This is why I'm doing these webinars. This is what I'm all about. Is it's time to turn all of our resources to repairing the natural world. Period. We have to create forests, soils, clean water, clean energy, secure communities, stable regions, stable economies. We know how to do it. We're going to learn from one another, and we're going to learn from the book of nature to create systems that are ecologically sound and economically profitable. And that's why we're all here, and why I'm doing this week after week. And of course, restoration agriculture is the designing of agricultural systems modeled after natural plant communities, natural biomes, ecosystems, etc. Not just, I guess I'd say, artificially contrived systems such as many permaculture guilds, but actually mimicking natural plant communities that have a long historic track record of success on this planet. And of course, producing food, feed, fuel, medicines, fibers, and living a good life. You know, it's actually quite a nice life. We've already talked a lot about these various different topics in succession. Succession is the change of species composition, the types of species, the kinds of species, plant and animal in a system, or the replacement of one type of system with another. Everything changes in a system. The soil life changes, the plant life changes, the animal life changes. The biomass accumulated on the site is different. You just think of a plowed field, how little living things are actually there versus like a old growth redwood forest. Look at the total difference in biomass on the site. So succession is characterized by a change through time of the structure, that's the shape, you know, tall, short, fat, skinny, etc., the kind and the abundance of the dominant species. Ecosystem change never stops. It goes around and around and around, and we'll see a couple of different fascinating pathways tonight. Some topics that I've used these words before, but I want to make sure that we have a clear understanding on it. And one is tolerance. When we're talking about plants in an ecosystem and their tolerance, it's mostly their shade tolerance. How happy can they be living in the shade? But it's other factors are involved too, because if you're in the shade of a forest canopy, like over here, and this mature forest stage here, you're obviously going to have less water striking the ground. So if you've got a meter of rain falling here, a lot more of it will be able to strike the surface. Whereas here, it's going to be a whole bunch of the water is going to be intercepted just by wetting the stems of these trees. A lot of it's going to be soaked up by the roots of these trees, and there's a lot less water involved too. So the tolerance also involves other issues, nutrient balance and water balance. But it's typically the early successional plants are very shade intolerant. They need to live in the full sun. That's where they live and that's where they grow. If they get shaded at all, they're not tolerant of shade. They die. Mid-successional plants are somewhat tolerant. Perhaps they get started in shade, and oaks are a classic example. They can get started in light shade and they'll grow for a few years. But unless there's a fire or some other kind of disturbance that will release them from the understory, they'll eventually die in the shade. Late successional plants, on the other hand, are extremely tolerant, and some of those are, for example, red maple and sugar maple. Beech, both American and European beech, are extremely shade tolerant. A lot of the hemlocks in North America are shade tolerant. Quite tolerant, and they can, while I remember the statistic, sugar maple seedling can live in the understory sometimes up to 250 years and never get taller than knee high. Then as soon as there's an opening in the canopy, it pops right up and it can fill that opening. So tolerance, we're going to be talking about that every once in a while. Or also late successional and early successional. I know I'll address this in another slide. Early versus late. These are time sequence words. Early succession is when the system is either coming out of disturbance and that's early in succession, so it has a particular look to it, a particular physiognomy to it. Then the late succession has a particular look to it, and although that depends on where it's located in the world, rainfall patterns, et cetera, advance. Of course, remember primary succession was ecosystem change that occurs on previously unvegetated terrain. Secondary succession is community change following disturbance, and here's this blowdown. We've seen this picture before of the blowdown. And obviously, agriculture is a disturbance. Back to early, middle, and late succession. What happens here is in the background, there is a forest. This is a closed canopy forest. In this particular area, the closed canopy forest was cut down, logged off, and the system went back in successional time to grassland. They grubbed out all the stumps, they burned them all up. That was backwards in, that's setting succession back to early successional stage. Plowing the ground and then eroding it is taking it even further back successionally, whereas going forward in the successional time towards a more advanced system, a savanna system would be somewhere in the middle, that it's got trees and shrubs and grasses, a closed canopy forest full of shade tolerance, and we'll see some of those. That's late successional. So this is extremely early successional. This is kind of mid-successional. See a lot of shrubs in here, and then some tall trees, and then later on this is later successional. That's different. It's a direction in time. And of course, all these different factors come into play. And everything is site-specific to a certain extent. All of these factors, the different site conditions, the disturbance factors, the organisms that are colonizing the site, their life patterns and behaviors and all that, from longevity to shape, regeneration strategies, all have an effect on system change. And as the organisms that occupy a site go through change, they're changing the site itself. So the site conditions change. It's a constantly moving target, but it's fairly I was going to say simple to work with. It's fairly easy to understand once you start having a relationship with your system. These are the different things that affect succession. We've talked about many of them. And over here on the left, these phases, these aren't hard. There's not like a hard line between each one of these, from stand initiation, stem exclusion, understory reinitiation, and old growth. But these are very helpful in us understanding our successional place in time. What phase is your particular property going through at this point in time? Is it agricultural field just being planted to new species, or is it a closed canopy? Let's take many places in New England, for example, especially in the suburbs. If you fly in, going into Logan Airport, about a third of the state is populated with a population density of about 1,000 people per acre. Highly, highly populated area, and you can't even see houses because this is an old growth. Some of these trees are 200 years old. So this is just at least useful for us to understand where our site is located and what strategies might we employ to either move succession forward or backward as we manage our site in this dance in time. Disturbance, obviously the clear cut. We've seen this picture before. Phase one. We decide to also, instead of just having it be some sort of random natural disturbance, we are intentionally disturbing our sites, and we as restoration agriculture practitioners will disturb our sites with types of disturbances that closely mimic natural disturbances to which those plants are adapted. This is in a southern pine region in, I believe this one is in North Carolina, USA. These are fire-dependent systems. They're accustomed to being catastrophically destroyed by fire, in this case right here, having a lot of mineral soil exposed, and then any residual trees like this left behind are now at risk of wind throw because they're not being sheltered by one another. So we'll go in and we'll do a little bit of disturbance on our own, mimicking our pit and mound architecture, managing our water resource, reseed it, plant whatever trees we want. This we've seen this is in Virginia, USA. Most of the trees that we see in here were actually either seed that blew in the wind. They're remnants of old stumps that resprouted or root suckers from trees that were already existing. So the establishment phase at the very beginning. If you're on going into ag land, here we are. We're using a tree planter, putting trees in the ground. Fairly high density. These are young chestnut planted right into the sod. The advanced regeneration is any propagules that were in place at the time when the disturbance occurred. Like I said earlier, it's either root suckers of plants that will propagate by roots, stumps that stump sprout, that coppice well, seeds that have been lying dormant, waiting for the opportunity to sprout, but they've been too shaded. All of a sudden, the disturbance removes the canopy shade. Pow! They just grow like crazy. Anything that has been there and sprouts once the disturbance occurs is all considered advanced regeneration. Then we get to the stage, and this is actually a very significant stage, and I wanted to spend a reasonable amount of time on it tonight. Once the site is fully occupied, I'm going to flip back here and just look at that right there. That site is about as fully occupied as you can get. There's hardly any room to plant another, plant in there at all. Hardly any exposed soil that you could get a tree or a grass into. Once you get that site fully occupied by individuals, the process begins to occur where there's facilitation, where some species are helping other species to get established. There's actually some mutual, just a neutral balance between the two. And then there is a competition that takes place between some. Some trees actually do, they actually do kill others. It just happens. They're competing for resources, and different species have different strategies on how to survive in heavy cover like this. Some of the first trees to go in a system like this right here will be the ones that are the least tolerant. They're the least tolerant of shade, and they're the least tolerant of competition for nutrients and moisture, and they have been losing the battle for a piece of the sky. These trees are all trying to get some sunshine. They've got to have sunshine to photosynthesize. They're all trying to get a piece of that forest floor with their roots in the ground so they can actually survive where they're at, and some of them lose. And typically the ones that lose first are the least tolerant ones, the most dependent on sun and open space. This is an example here of coppicing in my chestnut coppice agroforestry system I showed you before. There's a row behind here that has not been thinned yet. That row is at the stage, and it's a double row, 18 inches between plants, 3 feet between the double rows. That is actually at the stage where there are individual chestnut trees that are losing the site competition. If you look at this little scrizzly one right here, this is quite possibly on the way out. It's about to die. So what I do is I go into this system here. I've already marked trees for early reproduction because that's important to me as a farmer. I also have marked trees with survey ribbon for high yields and early ripening in the season. And those are the trees that I want to select. And one of the things that I've discovered, it seems to be very strongly correlated. There's only so many resources that actually reach each individual tree. And the tree has to make some sort of resource partitioning. Is it going to use that sunshine and water for immediate stem growth, or is it going to put it immediately into reproduction, or is it going to put it into storage in the roots so it can survive the winter and come back next spring? And it appears to me that the trees that are putting more of their energy into early reproduction and higher yields of nuts, they just don't have enough energy to put into growing big, tall stems. So when my chestnuts get to the phase where I'm seeing chestnut trees die, it's at the stem exclusion stage, I go in and I'll make sure that I exclude the stems that I don't want, and I favor the stems that I want. So there's right there is a perfect example of how we interact with this system in exactly the same way that nature would. That back row will experience stem exclusion. Well, the front row, right in front of us here, you can see some of these, the sprouts coming back. This is taken in the fall, obviously. It was coppiced late winter. We did some stem exclusion. We've disturbed the site. at the same phase that nature would do that anyways with the ones in the back. The difference being, of course, that we've selected for different traits than the randomness of nature would, or the weather on the site, or whatever natural disturbance would occur, or just mortality. The ones that would most likely survive would be the ones that are more shade tolerant, able to survive with fewer nutrients, and perhaps don't reproduce as young. Maybe they're just putting it all into wood, like this one in the center wants to go straight and tall, hit the sun. Just another view of what it looks like. Notice the grass coming in, because I'm managing for this open savanna type system with grass and the trees. I can get both forestry and agriculture happening at the same time. Another reason why we want to manage this way at the stem exclusion stage is that the trees will be growing at their fastest. This is the time in their lives. And notice this graph. This is time. This graph goes up. They're getting established. This is stand initiation. Well, then all of a sudden, during this whole growth period here, there's the stem exclusion phase. This length of time here could be hundreds and hundreds and hundreds of years. You could be at a place and you're basically just removing trees for the rest of your life, the rest of your children's lives, and so on, simply because the trees are continuing to grow and occupy that space until they reach this phase of old growth, which is fewer trees, but larger trees, and then openings that occur within that old growth forest. And if we look at this in the early years, we have far more trees. This is total number of trees. And then as the trees get older and the stems get bigger, there are fewer and fewer and fewer. Now, naturally, in a forest where we don't manage anything and it's not disturbed, this right here represents the whole stem exclusion phase. Trees are dying all the time. In order to get from a young, fully stocked, newly initiated stand of trees to an old growth forest, there are lots and lots and lots, thousands of trees that die in order to get to that phase up here. So the more trees we have, the smaller diameter they have to be, just because there's only so much space. As the trees get bigger, we have fewer and fewer trees. Well, we insert ourselves into that process by removing the trees that we're selecting against. And of course, we want to do that in such a way that we can derive income and food from it as we're doing so. Back to the stem exclusion phase. Notice all those stems, oodles of stems, trees are naturally dying. Here is a place, there aren't as many stems, and there aren't a whole bunch dying and falling over because I've already cut those down. And I'm going to be taking out the more crooked ones, the ones that are taking up more space than they need to, the ones that are blocking the sun from reaching openings. So I'm going in here and managing this, and we'll talk about forest management in a different webinar series at some point in time. But this is all inserting myself into the stem exclusion phase of this forest. And as far as I can tell, I can probably, at least me personally, I'll be able to cut from this patch of forest right here for the rest of my life and keep the whole house with just the trees that are there. You can see larger trees, fewer of them. There's more individual trees, small diameter. And bigger. And then until we get to this size here, we get the gigantic trees. This is more in the old growth phase. Now, old growth forests, I'll show a graphic later on, aren't all just old trees. There's a whole mix of different age classes of trees. And there are some that come in the understory. The understory reinitiation phase happens fully shaded. Others get established in these little sunflecks. There are trees that are so shade tolerant that all they need is a few minutes of light. And there's all kinds of data. It's really fun if you're a tree geek, reading about these different forest patches, and they do light meters. These little trees here are probably extremely tolerant. Sometimes what happens is you get like this two-phase growth, whereas the first trees that grow over the top are less tolerant than the later successional trees that come along. And a great example of that is like ponderosa pine, at least in the west coast. In the higher elevations of the Rockies, ponderosa pine comes in first. It's not very shade tolerant at all. It's somewhat fire dependent, but all of a sudden, if the fire does not happen for a certain period of time, the trees the lower branches all fall off the trees. They decay on the forest floor, so you have like this needle-like forest floor. Well, then if it's moist enough, you'll get silver fir and Douglas fir that comes in underneath in the shade in these little sunflecks. And then they'll grow as these giant ponderosas get bigger and bigger. The fir trees slowly kind of move their way up. And then eventually, as the ponderosas get old and fall apart, that releases the fir that's been in the understory. And a similar thing happens in the eastern half of the U.S. and actually a lot in the West as well, with the various different pines like sugar pine and western hemlock on the western part of the U.S., or white pine and eastern hemlock in the eastern U.S. I think up in Manitoba as well, there's still, as far as trees are concerned, I think there's still white pine up there and eastern hemlock. So then the understory reinitiation stage, we already talked about this last time here. These new trees get established. They're ready to be released somehow. If we go back here, if we were managing this system, we might look around at all the trees that are around here and see that maybe this one right here has some sort of disease and it's about to die anyways, so we would remove that. It would open up this little spot here, and now we got more sun and more water to these young trees that have now gotten started in the understory. So I've already mentioned it, that old growth stands are typically not uniform, gigantic trees. Of course, it depends on how big of a circle you draw around this. But undisturbed, no fire, no wind, no major disturbance for a long period of time, however old these oldest trees are, hundreds to thousands of years sometimes. What you'll get is you'll get one or two trees that just get old. They get old, they rot, they fall apart, they get struck by lightning. Well, when they fall over, maybe they knock over a couple other trees with them, and they make a little gap in it. And so old growth forests are typically old trees and mixed with various different age classes of trees all through it. That provides opportunities in these gaps where a tree falls. This is oak in Virginia, where this oak has died. All of a sudden, all this understory reinitiation now has a chance. Now, forest trees can reach a canopy either following a catastrophic disturbance, like massive blowdown, and we'll see pictures of catastrophic disturbance again, establishing in gaps like this right here, a gap in the forest, or rarely by a continuous regeneration in a disturbance-free understory. And I'll show it one example of a place that does that, where the trees just keep growing in the shade. They keep growing older and older and older until the original large trees just they hit their old age and rot and fall over. And the process continues with shade-tolerant trees sprouting in the understory. So the understory intolerant species, the species that are not tolerant to shade and shortage of water, typically utilize a major disturbance mode. These are classically a lot of the light-seeded evergreens, birch, aspens, willows. They're usually a shorter-lived tree. They don't live as long as some of the more tolerant trees. And they're the colonizers. They're the early colonizers. They go in there and take over the site following a major disturbance. They need that sun, so they need a disturbed site. So don't get stuck on some of the permaculture propaganda saying that you can't disturb the soil, you can't turn the soil. Well, there are certain plants that will not grow unless they have bare exposed mineral soil to grow on. And so we just have to understand disturbance and use it as a tool graciously and kindly, please. Your mid-tolerant and tolerant species will regenerate in these gaps. There's a whole entire school of ecology called gap dynamics, and you can just study different ways that the trees behave in these gaps. How big does a gap have to be in order to get some intolerant trees to sprout in that gap, versus how small can the gap be before you exclude certain species. One of my favorite species where I live right here in Wisconsin right now, and also on my properties in Maine, is the oaks. The oaks are a fire-dependent species. They are their original disturbance regime that they've lived with for zillions of years is basically over. You know, people are not letting the oak country in the USA burn anymore like it used to, and so what's happening is across the board, as a major dominant species in the forest, oak is it's disappearing. It's still around. It's not any threat of becoming extinct. It's just not regenerating because it doesn't have big enough gaps. And so what I work with a lot is I look at my understory reinitiation, and if I have a place that has a lot of young oaks, I can let them go for 3, 4, 5, 6 years, 10 years or whatever, but then all of a sudden when I start seeing those little oak seedlings die, I go in and I make a hole that's big enough so that those oaks can at least shoot up and dominate the immediate vegetation near them before the trees next to them bring their branches in from the side and close the hole more. And then maybe that's 5 years, 10 years. Then I'll go and maybe move take the next few trees away, the ones that have pushed the branch across the hole. So studying gap dynamics, for those of us who are going to be living with and interacting with our system, it's very useful to learn what we can. This is just a simple graphic showing here, we got this little tree, this WA. Seems to me that this could be sugar maple, and that could be red oak. But WA, what the heck is a WA? So the WA tree died, and all the reinitiated understory here now gets a little bit more sun, and it grows. And it looks like we got some of the WAs made it to the canopy, and some of these guys didn't make it to the canopy. And if this is red oak, if you got red oak here, it's got to have an opening in order to survive. So now if we got a red oak over there, we know that red oak is doomed. It's going to die. So we can remove it if we want to take small diameter material from mushroom logs, or if we want that red oak to survive, we might want to take out that sugar maple and this WA, so now the red oak is the tallest tree there, and then it can come and dominate the canopy. So this is just, look at these little figures right here, and if we know the different characteristics, sugar maple is extremely shade tolerant. Like I said, it could live 250 years in the understory and never get taller than knee high, and it's perfectly fine. Red oak is an intermediate tolerance. It can survive a little bit in the understory, but it needs that to have a place in the canopy eventually. So just knowing the different behaviors of the trees, the different tolerance levels of the trees, we can now play with this forest structure through time, extracting a value from it. If you're in an area that gets good spring sugar weather with below freezing at night and above freezing during the day, maybe you want to favor the sugar maples. Sugar maples are one of these very tolerant species that will actually regenerate sugar maple on sugar maple on sugar maple on sugar maple. We don't know how long because sugar maple country is just recently out of the ice age, like the past 15, 20,000 years or so. Here's a case of an example of a shade intolerant tree. This tree is not shade tolerant. It was one of the first ones to come in. This is at a place that 20 years ago, this was a young field that had just been colonized by several different tree types. One of the classic pioneer species trees, it's an evergreen actually, is eastern red cedar in the USA. Juniper, as some people call it. It has a seed that is ingested by birds and deposited in a bird poop. It is able to go right into a grassy sod and wiggle its way down to the soil, touch the soil, and somehow it's able to survive on hardly any water because the grasses around it are taking all that water, and it's getting enough shade because that grass is only so tall. It's not like 15-foot tall jungle grass. So the red cedar can come up and dominate a site. Well, red cedar will easily go away if you have other advanced regeneration in place that will eventually overtop it. And so that's what happened right here is this eastern red cedar was shaded out by its neighbors. This happens to be basswood, another classic late successional, very shade tolerant tree. What I like about basswood, because they're so shade tolerant, you can coppice them in the middle of a closed canopy forest, and they'll sprout up. You get all these delicious leaves. The leaves are very good in salads. They're very succulent, and if they're grown in the shade, they're even more tender than basswood leaves that are grown out in the sun. Obviously, basswood trees, linden, as they're called in the UK, I guess, once they're this tall, they produce a tremendous amount of honey. The flowers are just absolutely amazing in the summer when they're blooming. And in the cool of the evening, as the cool air is sinking, because this cool air is heavier, as it sinks by these basswood trees, you can just feel this waterfall and smell the most incredibly tasty waterfall of basswood blossoms coming down the side. And here's a classic gap in coastal redwood in California. Boom, tree goes down. And this is just a graphic of gap dynamics. Redwoods are actually very shade tolerant themselves, and sometimes they'll replace one another or themselves, and they'll regenerate over and over and over again. But as we've seen in a couple of different slides, where there's Douglas fir around, silver fir, they can be undergrown, or even western hemlock, they can be undergrown with this shade-tolerant western hemlock. If a fire gets in, then it can torch out and burn off the taller redwoods, and so that's obviously disturbance here. But you can get a replacement of the intolerant trees with a more tolerant species, or in the case of redwood, they're shade tolerant, but hemlocks are even more shade tolerant. And here's just another example of these little tolerants. These are probably, they look to me by their branching pattern, they look like some sort of fir, probably Douglas fir. These are, once you start playing with gap dynamics and the species that you have, remember that we can manage our site by removing individuals. We can also manage our site by adding individuals. The ones that we add, if we're going into a closed canopy forest, we'll have to, if we apple tree underneath the shade of a maple forest, it's going to die. It's over. It can't do that. However, if you make a gap, then plant your trees into the gap, now you're going to have to manage that little that system that you've put in that gap and manage for your values, whatever those are. And these are just different possibilities using the same basic beginning setup here as the gaps go on. And remember, we create gaps, and we can go remove these, remove these, remove these. And I have a question, Wayne, if you could just answer real quickly here. Are people able to stop me from rolling through the slides when they do a replay? Can they go to the slide and just freeze on it for a bit? Because this is a really useful to be able to do that with a lot of these slides. So because I do
Absolutely.
Okay.
Mark, absolutely. Yeah, that's the really cool thing. They can stop and pause wherever they like, take notes, and then, as I said, we're going to do indexing to where they'll even know that certain slides you have are at certain places in time.
Good. Hey, and actually, Tristan Vitale, I think, has got it pegged here. I bet you WA was white ash. That's actually a fairly intolerant tree, and the reason why I think he's right is because most of where I was getting this stuff from was Warren Woods. Warren Woods in southwestern Michigan. It's just maybe 3 miles east of the Lake Michigan shore. The Warren Dunes State Park is right on the shore. It's an amazing study in succession from massive disturbance all the way to an old growth system. And then just like 2 miles inland, there's one of the largest beech maple, old growth beech maple continuous recruitment models in the USA. And so tolerant species may use that third mode if the overstory is not too dense. And they do require some canopy thinning, like a branch goes down, or disease strikes a few branches, wind breaks off a branch, because they even beech and all these trees holding their leaves. This is all American beech. European beech behaves the same way. I've seen some beautiful beech forests actually in Croatia. It was beech over beech over beech over beech, and they would just keep doing that forever. But these guys, they have the ability to go crazy horizontal with their branches and just slowly grow and slowly grow. So the Warren Woods is a place that I've been to. This other place in Croatia, it's near Vukomarich, that I've seen. Really beautiful example of a continuous recruitment of shade tolerance into the canopy. Now with Warren Woods, it's a mix of sugar maple and beech. That's just a sign. Yes, I actually was there. And some amazing trees. And what I thought was fascinating about it is I thought that when I went in there, it would be this totally dark and no vegetation on the ground because it's just too shady. But what you see is you see all these age classes of trees. Some of these gigantic beech, couple hundred years old, and then you see gigantic sugar maples, couple hundred years old, and then you see these broken snags. Something happened here, and this all top breaks off. And look at the sunshine coming through, and that's just enough sunshine to wake those trees up on the ground. And I do know that one of the fascinating studies at Warren Woods is sugar maple is able to tolerate shade in the canopy for a longer period of time than beech. So if beech and sugar maple establish in the understory equally, and there's no disturbance, the sugar maple will last longer, the beech will eventually die. Well, if there is a gap, the sugar maple has the ability to elongate more quickly than the beech does. So if the site is more heavily seeded with beech and there's fewer sugar maples, that's when it's dominated by beech. So there's this dance going on between these two extremely tolerant species, and they're just constantly replacing one another in the canopy here. If you ever have the opportunity to go there, I highly recommend it. It's just pretty boardwalks, go through swamps. And notice, not all the trees are gigantic trees. They're all different age classes in there. And it's amazing when you go to old growth forests, that one's in Michigan, go to the west coast. I like the Tongass National Forest in Alaska. Amazing the amount of dead material, because one of these trees falls over. It could take 100 years to decay. And it's just as important to the ecosystem as a standing dead tree, all kinds of wildlife habitat, as it is on the ground slowly rotting away. So we've learned a whole bunch of stuff. We've talked about our stand initiation, stem exclusion, our understory reinitiation, old growth phase. These are the various different phases of an ecosystem on planet Earth. And if you guys are living terrestrially, and I think most of us are, wherever you live, this process, this four-step process, is occurring. Of course, it happens faster in some places, slower in others. The limiting factors that would slow it down are extreme cold temperatures, extreme hot temperatures, shortage of water, excess of water. All those things will affect how fast it goes. Let's take Arizona, for example. Somewhere in the middle of pink slick rock desert, that actually is undergoing succession. It's slow, and it's going to take a long time, and the eventual, quote-unquote forest that grows there is going to look radically different than something up in Vermont and New Hampshire that gets 60, 70 inches of rain a year. So your place is undergoing this. It's in our best interest to understand how this works naturally so we can insert ourselves into the system and act as another part of nature and help the whole system to be healthy and productive. We've learned a little bit about the intolerant, the mid-tolerant, and the tolerant species. Basically, it's shorthand for it's not shade tolerant, it's kind of shade tolerant, very shade tolerant. There's major disturbance regeneration. There are species that require major disturbance or they won't regenerate. And so if you are against cutting trees, that is against a third of nature. I mean, that's how a lot of trees regenerate, is by having that top removed either by fire or wind. Catastrophic regeneration is natural, it's normal, especially up in the whole Canadian Shield there. That is a major wind and fire disturbance ecosystem, that whole thing. And gap dynamics and continuous recruitment, these are the later successional models. We need to learn to see how this works without humans, so then we can work within the system and utilize these processes. Because if we're not working in concert with this, we're fighting against it. That's another one of the big permaculture principles, is we want to work with nature, not fight against it. How can we work with nature unless we understand how it operates? How can we work in a system that requires major disturbance for proper regeneration, health, and productivity if we have a concept in our mind that says you can't cut trees or you can't disturb soil, those aren't based on observations of nature. They're based on a partial observation of nature, and it's held as a concept, and it is a limiting concept in circumstances where that disturbance, major disturbance, is critical for the regeneration of the resource base. So let's go look at this beautiful little forest here. This is we're going to Colorado today. This is in southern Colorado. This is pinyon juniper forest. It's fairly closed canopy. You see there's still some openings here. It's not so closed canopy that that the forest understory has died away completely. It's still a forest understory. Pinyon pine can live in moisture sites, but it typically doesn't, well, it's not that it doesn't, it's just that it gets outcompeted by other trees that are more aggressive growers in the moisture sites. So it can actually grow with more moisture, but unassisted by human beings. In moisture sites, more fertile sites, other trees would take over. But this is a fairly closed canopy forest, pinyon and juniper. What's fascinating about the pinyon juniper vegetation type, it covers over 100 million acres across the western USA. It's like 40 million hectares for you Europeans out there. Pardon me, but that's a lot of land. 100 million acres. There's more acres of pinyon juniper in the USA than there are acres of corn. Think about that for a second. There are more acres of this tree that produces these amazingly tasty, highly nutritious nuts. More acres of that than acres of corn. Does this or does this not represent a huge potential staple food crop? How is this if we're supposed to plow up an extra, we have to double the world's food supply in the next 50 years or half the world's going to starve. We have amazing resources that we're surrounded with, and we're not seeing it because this does not look like agriculture to most people. To me, this does. This is a fairly closed canopy pinyon juniper stand. Both pinyon and juniper are fire tolerant, fire adapted species, and so they will behave all of the rules that fire adapted species do. And is this or is this not an ecological model for growing food? Isn't this perennial already? We have perennial, we're surrounded by perennial agriculture. We don't need to reinvent the wheel. Nature's got this figured out. All we have to do is observe it, interact with it, and accept feedback from it. And, if I have to keep ranting about this for the next 20 years of my life, that's so be it. And doesn't pinyon juniper thrive without our care at all? It does. You wouldn't believe the farmers and ranchers in Colorado that I talk with and consult with. It's like, that gall dang pinyon juniper just keeps taking over everything. It's like, great, I'm being taken over by food and money. What's the problem? What we got here, though, let's just look at this system. This is a little bit more disturbed system than this. It's more open canopy, so either it's a drier site, it may be grazed, and grazed, I would say, inappropriately because it's been overgrazed. There's some things that are at risk. The trees are at risk because we have branches low to the ground. If we remove the lower branches, go up 5 or 6 feet anyways, gradually, maybe 2 or 3 different times to trim that up. Then if a ground fire goes by, we won't be at risk of torching out and flaming out all of our trees. So if we were to help this out a little bit, we would do a mob stock grazing with a long recovery period because this is a very arid site. Give it a long period of time for the grasses to regrow. You'll get more carbon down in the soil that way with the roots. More carbon means more water can be stored, natural rainfall water, more soil life, pooping and peeing, which is more fertilizer, good for the grass, good for the trees. Carbon's coming out of the atmosphere, going into the roots of the grasses, going into the trees, and we're pulling out of the system, we're pulling animal proteins, and we're taking nuts out of the system. This is a very natural, a perennial agriculture, permaculture right here, if we understand how the species work, understand the disturbance regime that keeps this system healthy, and then actually interact with it and accept feedback for our actions. Now this is a overgrown pinyon savanna. There's a lot of mountain mahogany grows in there. In some places, moisture sites, you'll get gamble oak that gets thrown in there, all kinds of thorny, unpalatable stuff. And further south, you'll even get some mesquites in there. This is a system that has not had that disturbance. And if we just go between these past 3 slides, these different phases. Closed canopy forest hasn't had a fire in a long time. If a fire goes through here, it could be catastrophic. It could be a stand replacement fire. The whole thing crowns out. The fire grows right up to the crown of the tree, and all of them are burnt. And then the only things that happen is, remember, this is a fire-adapted species. The cones, there are serotinous cones that get heated, and that's what allows them to open up, and then the nut comes free. Now they've got bare mineral soil. Oh wow, did I say bare mineral soil? Yeah, the pinyon wants to have bare mineral soil in order to get sprouted, and it doesn't want much competition in the early years. Fire allows that to happen. So this is a little bit more open. This is heavily grazed, or there's been light surface fire going through every once in a while to keep the brush down. This has probably not been grazed, or if it has been grazed, the animals that went through there ate all the grasses away so that the grasses died and only the unpalatable shrubs grew up. So we can insert ourselves into either of these phases to increase the productivity of both the pasture and the pinyon trees to produce more pine nuts. This just shows a couple of different things, how with a pinyon forest, starts with like a fire-maintained grassland. The fire goes through, prepares the seed bed. Seed comes in, the cones pop open. If all of a sudden there's a fire, poof, there's a return to a grassland. The next slide shows that. Goes right back to grassland. Well, if the trees grow and not all of them die, it's a thinning fire. So now we've had stem exclusion. So we start our system higher density, we start removing stems. Later on, now we've got these taller trees, and surface fires can go through and burn the grass underneath. You got these kind of park-like systems. Well, we don't necessarily have to burn everything. We can use pruners and saws to do thinning. We can use mowers or livestock to do the grass removal. And then, of course, what happens is you get to these stand-destroying fire where the whole thing gets started all over again, goes back to grassland. So here's a successional circle, and depending on what we do, we can have these various circles. You could stay in this fire-maintained open parkland for a long time. Now, are there any other kinds of animals that might thrive eating grass in a pinyon savanna? Something besides mule deer. I'm sure we can find something. And did you know that there are over 20 species of pine nuts around the world? There are pine nuts that will grow on every single person who is on this particular webinar right here. There's a pine nut that will grow near you, period. There is. And so why not grow pine nuts and grass underneath? This is a perennial system. It requires our management in order to keep it productive for us. There are even pines that are tropical, believe it or not. The only place I think where we might not, there was a guy who used to come to these webinars from Svalbard. He could probably grow Siberian pine, but they might never get any taller than 3 or 4 inches tall, because the tundra is a pretty harsh place. So here's a pinyon juniper hillside in southwestern Colorado. Now, wouldn't it make sense, and don't you think that we could actually grow more pine trees and more grass if we managed the water instead of just allowing it to be squandered in a flash flood? This place only gets like 10 to 12 inches of rain a year. When it does, it all hits these, you can see where the valley is. It's the wettest spots right there. The water just goes whoosh and flows away. You can see where there's a little bit of erosion going on here. Why squander it in flash floods? Let's go start here. See if this sounds familiar. Water management. Let's build a pond there. Let's fill that pond with using some canals and berms, ditches and swales, whatever you want to call it. Let's do it because this is in a dryland area, more like a classic keyline irrigation system where we're going to capture water over this wide hilltop here and store it in this pond solely for the use of irrigation later on by gravity flow. So what we can do is either have a standpipe through it that goes into channels, irrigation channels, and then these irrigation channels either can move the water out or they can be perfectly horizontal and sheet the water across the system. The choice is up to your what you want to do. Don't you think that we'd be able to grow more grass in a system like this and more opinions in a system like this? Oh yeah, right. And maybe even have a variety of different kinds of livestock. Is this or is this not a perennial system? And is this or is this not more photosynthetically and biologically productive than it was before humans interfered and managed the site? I argue that this is. This business right here, this is the Hammonds Company in Stockton, Missouri. They organize the harvest, so people are out there harvesting this product. They organize the aggregation, bringing it all to one place, the processing, which means husking and cracking, then cleaning, then sales and distributions of millions of pounds of black walnuts from this facility right here. Does that represent economic development? What I'm talking about with restoration agriculture here is that we are going to go into degraded ecosystems. We are going to imitate the natural plant communities that would have existed there, and we're going to go heavy on the food, feed, fuel, medicine, fiber species. Then we're going to manage it like an ecosystem, not like a garden, not like a horticulture, not like an orchard, not like a landscape or a city park. We're going to manage it like an ecosystem, and we're going to harvest millions and billions of dollars worth of food products from these perennial systems that are obeying nature's rules, going in the same direction that nature is going in. Sounds to me like a new restoration economy has to happen. This is just from a study that was done at the University of Missouri in Columbia, that the world pine nut production right now is so small that the demand for pine nuts is so much greater than the available supply. That's the case with many, many different species. There are huge markets, 9 billion people on this planet that all need some kind of food. Why not restore ecosystems and produce that food at the same time? We get ecosystem services, we get clean water, clean air, we get food, we get wildlife. It's impossible to keep wildlife. Oh my gosh, you wouldn't believe the squirrels that are in my chestnut system at New Forest Farm. This is like the first year that all of a sudden the squirrel populations have just exploded. It's always been like onesie twosies here and there, but they are everywhere in my system, so I can't keep them out. Our farm used to be where the deer would go through. Now our farm is where the deer come from. We're a source of wildlife. There's been bears sighted at our property, and bears don't live for miles around. Why are they hanging out at my place? Because it's got lots of food that bears enjoy eating, such as gigantic chestnuts, hazelnuts, etc. We have wild turkeys. So if you're a wildlife aficionado, whether you take pictures of wildlife or shoot the wildlife, set up a restoration agriculture system. Manage it like an ecosystem. We're going to get natural ecosystem service benefits and food and fuel and medicine and fiber, building materials, and a beautiful, beautiful green place. Places like this. And then next time, what we're going to do, I focus pretty heavy on the pinyon juniper vegetation type. Next time, I'm going to do a couple different other vegetation types, different parts of the USA, and just show how we can interact with those different vegetation types, interact with them in a similar manner as their natural disturbance regime, and obtain a yield. And this right here is a picture from one of my trail cameras at New Forest Farm. This place, exactly where this picture was taken 20 years ago, was a cornfield. Well, there were 3 or 4 young bucks that had come to this particular spot. It's a set spot where they're marking, flirting. It's like a pickup joint, I guess, for the girls. And then all of a sudden, the picture prior to this, 10 minutes before this picture was taken, there was a buck with, in the eastern half of the U.S., we count both sides of the antlers. There's 5 tines on each antler, this big, beautiful 10-point buck. And then 10 minutes after that 10-pointer went by, this thing walks by. And I haven't finished counting them all, but there's a brow tine here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15-ish, at least 16-point deer. That's the only picture I've ever seen of them. but there's a monster buck destroying a lot of my like 6-8 inch diameter trees, and I think this is him right here. We can have nature and agriculture coexisting simultaneously when we design our systems after nature and manage them using the natural, normal disturbance regime of that vegetation type. And that's what I got for tonight.
Awesome. Mark, stay on this picture. I don't know if you're going to move it, but you know what hit me initially? I also looked at the rack immediately, but this picture, and I'm not sure I've seen another like this, shows how well these animals mimic their environment. If you took his ear out of this, okay, and his butt, which his rack looks just like all this vegetation around it. Look how that's what hit me first as I was looking. Whoa, that rack just fits totally right in with everything that's around it.
It's just another kind of tree, you know?
Yeah. We've got some great questions here. People throw in a few more, and I'm actually going to go back to one that we actually had on our little session we have on Monday nights now, and it's a little bit off topic, but not totally. And this is from Lynn, and she asks, if you've used your stun technique, I'm paraphrasing your question because I know what she asked, and you've gotten excellent growth, and you know they're too crowded, they're too close now. At what point do you know it, and then when and do you transplant them?
Well, this is where the observing nature and interacting with it and accepting feedback comes in, because what will happen is you will know that you should have done it last year when you see trees die this year. And then you say, okay, if I got, whether they're chestnuts or pines or whatever I'm looking at, I should have thinned them out earlier than that. And you kind of figure out, it's not always age either. It's the vigorousness of growth, how healthy and vigorous those trees are growing. Some trees will actually be chronologically young, but biologically old because of the competition, and some things vice versa. That may take a few years to get there, and they're old geezers, or they can be very old years-wise, but still a young, healthy tree. I know on one of my webinars I showed this oak. It's like 3-foot diameter, and that thing's growing like a teenager. It's amazing how fast that's growing. So you're going to have to observe that. And yes, I do transplant on occasion. I'll start things in transplant beds and plant them out. And actually, the Forest Agriculture Enterprises nursery, that's what we're all about. Our pine nuts, our hazelnuts, and hybrid chestnuts, or Chinese chestnuts, they're all planted in high-density nursery beds. And we only keep them in there for a year. Then we pull them out and transplant them out. And then when I'm personally transplanting on my farm, I plant them too close together because I want to roll those genetic dice and increase my chances of getting superior individuals.
The second part of her question, she says how. So is it with a shovel? Do you have a special device? How are you transplanting those young trees?
One of my favorite ways to do it is around here. I don't know what the circumstances are near you, but around here it goes from winter when the ground is frozen, then it thaws, but it's cold and wet. And at that point in time, the trees are all dormant. And with this cold, wet, muddy spring soil, I know in mud season in Vermont, New Hampshire is a classic during mud season. Then I just go and you yank them out of the ground, and then you go put them in somewhere else. Or you use a trowel or a shovel. In a nursery bed situation, it's like a hula hoe or a stirrup hoe that is on the back end of a 3-point hitch tractor, and drop it in, and it kind of wiggles back and forth, and it undercuts all the roots, and then you just pick up the trees and transplant them that way. So whatever tool you've got. I like to do it in the spring when it's still cool, the trees are still dormant, and get them out of the ground and transplant them.
And Lynn's the one that's up in the North Country, so I'm sure she gets that mud time in the spring. All right, here's a little bit longer one. I've heard Mark mention mineral soil being important for certain tree species to even sprout. I'm currently working on readying a site for a stand of Siberian stone pine, direct seeded. Would it be best to disturb the soil itself, providing some mineral soil for sprouting, as well as clearing to allow full sun, or will the organic layer not represent an impediment to sprouting?
What's fascinating about the stone pines, Korean stone pine, Siberian stone pine, are very similar this way, is those little SOBs for some reason don't like to sprout. And I don't exactly know what the trick is. My nursery guy, Tom, who does all of our sprouting of trees, curses me more over the stone pines than any other tree that we do because they just misbehave. The bare mineral soil is important. Probably a good leaching. There's probably anti-sprouting. There's sprout inhibiting hormones in there that prevent it from sprouting. Because you think about this is a fire-dependent thing. It's supposed to lay down there and not do anything. Maybe it needs heat. I don't know. Maybe it needs a certain amount of heat, and then a whole bunch of them will sprout. And yes, the mineral soil, especially with your pines, because they're such tiny little trees, and they really can't handle excessive competition when they're small. Well, now what's also fascinating is I'm told that I do a little bit of research that Korean pine, anyways, requires light shade when it's little. But not when it's bigger, because then it's very intolerant. And that reminds me a lot of longleaf pine in the southeastern part of the U.S., where it'll persist for a little while, but it's got to have a fire to come in and clean out everything else in order for it to dominate. So with my Korean pines, is I'll plant them into a sod strip. I've subsoiled first, so it's only like 6 or 8 inches on either side that's kind of bare soil. Transplant into that, and then give it a few years of hopefully surviving, and then I mow on either side, kind of mimic the fire thing. So yeah, Siberian pine, go for it. Love it.
Awesome. That was Tristan, by the way, that asked that. Here's an interesting one. Isn't juniper considered to be more of an invasive species due to its required excessive water consumption?
Well, first of all, excessive water consumption, who says? And excessive water consumption, that's a concept. That's not an observation. There is an observation, perhaps, that this tree requires this much water. That's a fact. So now if we understand how this tree operates, how much water it actually utilizes when we have them on a site, and we need to understand how that tree operates. Instead of immediately throwing up this concept that it's invasive, excessive water consumption, say, time out. What is it? How does it operate? What's its disturbance cycle like? How do I insert myself into this system so as to either favor it if I want to favor it, or not favor it if I don't want to favor it? And so just to understand how that tree works before using such word as invasive species and excessive water consumption. It is what it is. Let's figure out how to work with it. You're either gonna shade them out or cut them down. I like to cut them down. They're also very rot resistant, and then take them out into open areas where I've planted new trees, and just dig a post hole in the ground, and I plant this dead tree in the post hole, in the hole, and let it sit there, and eventually the needles all fall off of it, and then it's an amazing perch for owls and hawks and other birds of prey that now will go after the rabbits and the squirrels and the mice that might girdle my young trees.
All right, got 2 or 3 more is all. Is it, if I'm wanting to reforest degraded pasture, can I go ahead and plant late succession species, early succession species, or a mix of both? From Alec.
That's actually a really great question, and quite often I've run into situations. Here's one example. If you go to like the River Edge Nature Center, I think this one project they call the Wild Harvest Project or whatever it is. It's our restoration agriculture answer to this site. They got land deeded to this nonprofit, and the nonprofit's bylaws says that you will put it back to its original condition. Well, its original condition was beech sugar maple. Well, so they went out and they planted beech and sugar maple, and they failed to thrive. If you think about succession as this time continuum, the original site after agriculture, which this was, it was a cornfield, that soil is not deep, dark, Warren Woods, beech maple forest. And so we need to have some sort of succession occur through time to develop the proper soil for these trees to come in, and to develop the proper shade for them to come in. Yeah, you can get them to survive but at what expense? They had already tried to revegetate the site with beech and maple, and it was a miserable failure. So what we've done is we've gone in and we're doing a successional planting, an early to mid-successional planting with shrubs and mid-tolerant species to eventually get to the tolerant species. Now on New Forest Farm, I planted the very first year I got to the farm, I planted 20 acres of sugar maple. And I tell you, there's maybe 2 dozen, 3 dozen trees that are alive at all. They're only 10 or 15 foot tall. They're finally starting to kick in. Well, I also planted a lot of hazelnut and chestnut, which are more on the fire side, and they're early to mid-successional species. I have sugar maples blowing in from the outside, growing underneath my chestnuts that are 15 to 20 foot tall, but they didn't come in until 5 or 6 years ago. They came in, they found the conditions were right, and the growth was explosive. So I'd go ahead and plant the early to mid-successional species first and wait a little bit on the late. Can you believe it? Me telling somebody to wait planting trees? If you're going to invest this much in planting trees, give them a better chance. Or pre-inoculate the soil. Get a scoop of soil from whatever the deep dark forest type that you're looking at for your late successional trees, and put that in the hole to help increase your chances.
Awesome. By the way, that relates to the next two questions. What was the name of that black walnut harvest company again? So I can put it in the note here. Somebody asked that.
Hammond.
You show the slide up.
Hammond. I think it's Hammond. Hammond. It's in Stockton, Missouri. If you just do a search on black walnut, everything goes to them eventually.
Okay, I'll put that in the answer for everybody. And then this next one was kind of related. Are your trees sold bare root?
Yes. Yep. We lift them in the spring. During those conditions, what I was mentioning is we'll when the soil is wet, the trees are dormant. They're lifted, and then we put them in a cooler. Somewhere around 34, 36 degrees, high humidity. It's like a florist cooler. And actually, we've stored trees for a whole entire calendar year and put them in the next year. I wouldn't recommend that, but they actually, they did all right. They're asleep, 34 degrees. They're not going anywhere. As long as you keep them damp, they're doing just fine. So yes, we lift them and we sell them bare root. And in order to encourage people buying larger quantities, you plant a onesie, twosie of anything. That's not enough to feed a rat, let alone your family. We want to encourage people to plant enough that you can actually feed yourself. And so we sell them by the bundle. That also allows us to keep our costs down to the people who buy them.
Well, I don't have any more. Lots of people saying thanks. And Jordan actually did put in a source of that article that he must have read, and he made a little comment. Was apparently scientists in Oregon have discovered water consumption or something. I don't know. But everybody's saying great. Anybody else have anything real quick? One last question if you have it.
I'm not denying the fact that juniper takes a lot of water away from the system. If you look underneath it, it kills the grass underneath it, and it's not just poisoning it with the needles and the strange resins that are in it. It's also just consuming the water. What I'm saying is, instead of interacting with your world through a concept that it's invasive and it's stealing water, that's an idea that's in your mind. Drop that for a second. Observe that species. How is it working? How is it reproducing? How does it naturally change over time? How does the natural succession of that tree occur? When does it get to stem exclusion phase? Can I get to stem exclusion phase earlier? Or, whatever your choice is, understand the plant as it actually is with observable phenomena instead of ideas that we throw at it. That's all I'm saying.
All right. Well, we are past the hour. Lots of people are giving us some thank yous. There is one question here about references for disturbance regimes. Do you have anything that's off the top of your head, Mark? If not, I just told him we'd find some.
Not off the top of my head, but one of the things that is fascinating, and Pinion is one of them, that since ecology as a science is so new, there's not a lot of huge amounts, vast amounts of research on the various different disturbance regimes and the requirements of individual species. It's more for regions, and it's a lot more historical stuff. You just go online and you can find, put in disturbance regime of XYZ PDQ.
Yeah.
But pinion's one of the least understood species out there. It really is.
Well, I'm going to end it with this because this is great, and I'm going to say who said it, and a bunch of people said thanks, but let's end with this one. This has been awesome tonight. I put in a couple of things down in the public side of this, which was just saying we should learn from those slides. 100 million acres that we could be basically putting into a restoration, agriculture, forest, agriculture system. But here's what I'm going to end with. John Paul Learn says this: just want to share that the stock that I've received from New Forest Farm is superior and excellent quality. I've had a 100% success rate planting them out, hardy roots, healthy plants, great stock with 3 exclamation points. Thank you, John.
All right. Thank you, Jean Paul.
All right.
Yeah,
well, everybody,
we pride ourselves on big roots, that's for sure.
everybody, we actually have Mark who's helping us here. He's getting these replays done by the early tomorrow. I'm getting them done in the morning. I'll have this back up by tomorrow. I'm sure a bunch of you are going to want to look through. Remember, like I said, you can stop it and get notes. You actually have the ability now to download. So you could put it on, just save it on your computer and then look at it whenever you'd like. So another really awesome time with Mark. Tomorrow we'll have 2, actually. Remember, Neil Spackman's doing his second part of Greening the Desert, and then we have our alternative health concepts on the truth about cancer. And some of you have not been to that one. You'd enjoy that, or at least watch the replays from it. Thank you, Mark. Thank you, everybody. Thank you, everybody helping. And we'll see everybody tomorrow. Bye-bye.
Bye-bye.
All right. So most of you are still here. Hope you enjoyed this presentation from Mark Shepard. And what we'll do is we'll come back tomorrow and we'll watch another replay from Mark Shepard's Forest Ecology. We'll watch the next episode. So it'll be the next one. From this one, we'll watch the replay. And those of you who put in questions, I'll try to get in touch with Mark Shepard and then get your questions answered. Alicia put in a bunch of links and resources. Thank you so much. And those of you said very helpful. Okay. So once again, thanks a lot for hanging out with us, and we'll see you all tomorrow. Have a great rest of your day, and good night. Bye-bye.